nuclear force. Question number 5, A part. What causes two nucleons to attract each other? What causes two nucleons to attract each other? Why there was this question? Theory was that there are number of protons inside. At present, you have protons as well as neutrons. You term these combined as nucleons. Issue is, a proton will repel a proton because they have positive charge, but inside the nucleus they attract each other. So the theory was proposed by Henry Yukawa, scientist, that why two nucleons attract each other. The theory was, two badminton players can stay together. What they exchange is shuttle. Two basketball players stay together because they have one particle to exchange. That is the ball. This theory is termed as particle exchange theory. What they exchange is a pi meson. There is a particle, pi meson is exchanged between two nucleons. The theory was proposed by Henry Yukawa. So, as per this theory, the two nucleons exchange a particle. That is why they can stay together. 1 minute with you to write. Characteristics of nuclear force. Strongest force. At small distances, the value is, yes, strongest force or strong force ratio. Yes, force, nuclear force 2. Yes, electric force is how many times? Electromagnetic or electric is how many times? 100 times. But it is 2 at small distances within the nucleus. 1. 2. Nuclear to gravitational force. Nuclear to gravitational. Yes, value is how much? 10 power 38. Competition, you get question, force between two electrons, between two protons, between two nucleons. Because the masses will vary, that is why this answer you will get 10 power 36, 10 power 38, 10 power 40, 10 power 42 of this order. So it will depend on what? Gravitational force depends on what? Mass of 2. But again, this is true when it is of small distance. If it is at 1 meter, then it is, this condition is not true. This value is not 100. When they are at 1 meter, nuclear force will be very small. Electric force will be strong. That means what counts is the distance between the two. When the distance between the two changes, this ratio will also change. In the notes it was point number 2. This is, I will interchange. Point number 1 is what? Yes. So we interchange point 1 and 2. Independent of a charge means what? There is a force between a proton and a proton. There is a force between a neutron and a neutron. There is a force between a neutron and a proton. Competition. They write this way. Neutron force is same as that of proton force is same as that of proton force. This is the correct answer. In objective question, you will find the format, this one. Point number 3. Yes, short range. Of what order? Yes. Within the nucleus, 10 raised to power minus 15 meters. Fermi. That is within the nucleus, small distance. Time with you is 3 minutes to write. 3 minutes to write, point number 1 to 3. Nucleon. Nucleon means protons and neutrons combined together are termed as nucleons. Fermi is a distance. 10 raised to power minus 15 is 1 Fermi. 1 Fermi is 10 raised to power minus 15 meters. This order is Fermi. 1 Fermi is 10 raised to power minus 15. Point number 3 is graph. 4, sorry. Point number 4 is graph. Means force, distance graph. If you vary the distance between the two nucleons, force, distance graph, same as that of interatomic or intermolecular force. If it is above this point, that means along positive, the force is repulsive in nature. If it is negative, it is attractive in nature. And if it is the effective value starts from 10 for me, yes, 10 for me, some value. As the distance between the two nucleons decreases, force keeps on increasing. It becomes a maximum at certain value. And when further the distance between the two decreases, the force value decreases and becomes 0 at certain value. What is this value equal to? Yes, how much? 0.5 for me. Say this value is 0.5 for me. If you further decrease the distance, the force becomes, yes, positive means what? Repulsive. So this is the pattern. Force is attractive, keep on decreasing the distance. As distance decreases, distance between two nucleons, as the distance r decreases, force becomes maximum, attractive, and at this point, 0. Neither attractive nor repulsive. If you further decrease the distance, the force becomes repulsive. When distance between two nucleons is more than 10 Fermi, force is attractive and small. For distance less than 0.5 Fermi, 0.5 Fermi, force is repulsive. Nuclear force does not obey inverse square law. Doesn't obey. Inverse square law means this law. It doesn't follow this. Gravitational force and electric force both follow this law. Point number 5. Yes. Yes. Depends on spin. Means what? Two nucleons having a clockwise spin, force is different. One clockwise and other anti-clockwise, force is different. That means if there are two nucleons having clockwise force, F clockwise, one is clockwise, the other is anti-clockwise, this is, say, opposite spins. These two forces, this force and this opposite, are not equal. It depends on spin. 6. Non-central. Gravitation. Yes. Earth, ball, force acts along the line joining the centers of the two. That was central force. But this is non-central. This is not along the line joining the center of the two. That is, gravitational force was a central force. Electric force was a central force. But this force is non-central. 2 minutes with you to write.